is FlashText. So FlashText is a Python library that I have written. What it is used for is to extract terms from sentences. So say that you have a sentence like I love Big Apple and Bay Area, and you have terms like Bay Area or Big Apple, and you want to extract certain terms from the string. So to extract these terms, ideally you can write a regex. Most people would write regex. But as we go ahead in this video, you would realize that regex is slow in certain cases. Certain cases like where the number of terms that you're looking for is very large, especially like thousands of terms if you're looking for, regex is slow. Where regex works and what FlashText cannot do is to search for non-complete terms. Non-complete terms like in regex there are features to search for /w or /d components where you are searching for any word or any character or two characters, but you don't know whether it's A, B, C, or D, or any alphanumeric character. If you're looking for dot star like features, if you're looking for 4 numbers in a sequence, FlashText cannot do that. But when you have a known term like Bay Area or Big Apple have fixed spellings, or even if there are misspellings but you know the common misspellings, you could just add those terms to FlashText, and FlashText can extract those terms from any given sentence. Like if you look at this example, I have added Big Apple and Bay Area as known terms, and when I give a sentence to FlashText and ask it to extract the keywords, it just extracts the keywords that were given in the add keyword process. Also notice that it is not exactly extracting Big Apple, it's extracting New York, even though the sentence says Big Apple. So I've added a feature where some spelling which is a synonym and you want to extract a standardized name for it, you can do that. If you don't have a standardized name or the name is already standardized and you want to extract that, you can just do exactly that also. So from here, Bay Area is extracted exactly as Bay Area because I didn't give a standardized name for it. Another thing that FlashText can do is this, which is replace keywords. So if you have a sentence like I love Big Apple in New Delhi, and you want to replace New Delhi with NCR region, it will replace that with Big Apple has been replaced with New York because that was added, and New Delhi has been replaced with NCR region in this sentence. Again, the exact same thing can be done with regex, but as we go ahead with this video, you will realize that regex is quite slow when the number of terms is very large. How does FlashText compares against regex in terms of timing? So what I did was I created a document of 10,000 characters of different terms. And I created terms to search in those documents, and when we were searching for one document, inside one document we were searching for close to 5,000 terms. FlashText was taking almost 0.002 seconds almost always, and regex was taking more and more time. As the number of terms grows, regex takes more time. That's what is clearly indicated from this graph. Whereas when we reached around 15,000 terms, FlashText was taking nearly the same time, 0.002 seconds, and regex was taking almost 0.15 seconds. Now what happens is when we have millions of documents to search, multiply this time saved with millions of documents, and then we will actually get the time saved from using FlashText. FlashText makes a lot of sense when we are using it for large number of terms. Like if you have more than 500 or 1,000 terms, or say 10,000 terms, something like that. Yeah, so one last time going over the graph, this is the time taken by regex. This flat line at the bottom is the time taken by FlashText. And this is the number of terms on the x-axis, and y-axis is the time taken. Next is a simple example on how to use FlashText. So first step is to install FlashText with pip install FlashText. As you can see, my requirement is already satisfied. If you don't have that case, then you should just do this step, and that will take care of the installation process. The next step is to import FlashText. So FlashText is the module is written in such a way that there is a keyword processor class. Just import this class and create a keyword processor. Once this is done, then we just need to add our text, like a keyword corpus, to FlashText. So we just add keywords, J2EE Java. Basically over here what we are doing is we are saying that J2EE means Java. So whenever J2EE is found, return Java instead of returning J2EE. I can also skip this comma Java part, and then if J2EE is found, FlashText will just simply return J2EE. So the next step is keyword processor. We ask it to extract keywords from a given string. So in this given string, FlashText will try to find all the keywords that we have already given to FlashText. So from the corpus, if any of the terms are present in this string, it will return it. So let's run this. And we can see Java is returned from I like J2EE. Another feature that FlashText has, which is to replace keywords inside a string. So over here, we can see key I like JavaScript, and we want to replace this Java space script with Java without space script. Now, where is it useful, you might ask? So if you work with any form of Word2Vec or LDA or any sort of text processing where you're tokenizing the terms, if you're working with Elasticsearch, anything like that, you would be tokenizing terms. Mostly when we tokenize terms, we tokenize them with a space and other special characters. So what happens is JavaScript will get broken down into Java and script. So if there's a document which has JavaScript with a space in between, it will come in search results for Java instead of coming in search results for JavaScript. So we just want to replace this Java space script with a Java without space script. This is really useful for doing Word2Vec kind of a more embedding building with Keras or something. So let's run this. The idea here is we are adding this term, and then we will just call replace keywords, and let's see what it does. So it simply replaced I like Java space script with I like JavaScript, and that's the idea behind this step. And over here we were just extracting the terms present in the document. First part of FlashText is the try dictionary. Let's go over how we build that. So first we start with a start node. Then say we want to add a term to it, like Java. To add Java to the dictionary, we'll go like this. We'll iterate on Java character by character from left to right. And first we add J to a start node. Then we add A, we add V, and we add the last character A. Now we found that the term has ended, so we add a special notation which says end of term. And we also add another mapping which says term identified at A is Java. Let's say we want to add another term to it, which is J2EE, which also means Java, by the way. So this time we try to add J, but J is already there. Then we add 2. Then we add E, and we add another E. Again we reach EOT, end of term, and we map it to Java. Now let's say this is part 1 of how FlashText works. First we build the try dictionary, and then say we want to search on a string which of these terms are present in that string. That's what we want to find. So dictionary is ready to search, and say we get a string like I like J2EE, and we want to find out all the terms from our dictionary that is present in this string. So we go over the string like this. We try to find out if there is an I connected to the start node. It's not, so we skip over it. We try to find if L is there, because that's the first character of like, and that is also not there, so we go to J. Now J is present, so we move our pointer forward. 2 is present, so we move our pointer again. E is present, so we move our pointer forward again. And another E is present, and we reach E of T, which is end of term, and we reach an end of term in our dictionary also, which means that this term is present in the dictionary as well as the string. So we have found a term we will return that term, and that term J2EE returns is mapped to Java. That's why we will return Java as a found term. And that's how FlashText works.